Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein and I'm a PL/SQL developer just like you. This lesson is part of my series on programming with collections, the array-like structures of PL/SQL, and the focus of this lesson is using collection methods, procedures and functions defined that can be attached to the collection to get information about it or to change its contents. So, collection methods. The term method generally is used to describe procedures and functions that are defined in a class or an object type, and you invoke a method by attaching it using dot notation to the name of the type or class, or an instance of the class. This is different from procedural approaches in which you call a procedure or a function and you pass arguments to it. So, collection methods are procedures and functions attached to a collection variable. And what's interesting about this is it was the first introduction of object-oriented syntax in PL/SQL, way back in Oracle 7.3.4. So to be clear about the difference here, a method approach versus procedural approach, let's take a look at the method versus procedure file. Here's a declaration of a variable based on a predefined collection type in the DBMS SQL package. Now the delete method, which I'm going to talk about in more detail shortly, is attached to the variable using dot notation. Procedural approach would be to call the delete procedure and pass it as an argument, the collection. So in PL/SQL this is not what you do. Instead you attach the method to the variable itself and then it performs the operation on that variable collection. So that's the difference between a method approach and a procedural approach. So, there are two sets of methods, those that retrieve information, those that change the contents of a collection. The count method returns the number of rows currently defined in a collection, just like select count star from a table. Exists returns true if the specified row or element is defined at the index value specified. First and last return the lowest and highest index values of the defined rows. They can actually be numbers or strings. So the lowest and highest defined index values. Next and prior move you to or return the next, the highest up, or the previous, the next lower index value that is defined in the collection. Limit tells you the maximum number of elements allowed in a V-array. So these are the different methods for retrieving information. Let's take a closer look. The count method is probably one of the most popular. It returns 0 if the collection is empty. Otherwise, it returns the number of elements defined in the collection, the number of defined index values. So here's an example of calling the count method. Simply attach count with a dot notation to the variable name, and it returns that integer value, 0 or higher, never negative. The only limitation with count that I can see is you cannot ask for a count of elements between a range of index values. Find all the elements defined between 100 and 1000. You don't have that possibility, at least not yet. Checking for element existence. So, with collections, if you try to read or touch an element at an undefined index value, Oracle raises the no data found exception. Now I think this is a bad decision on Oracle's part. They reuse the same exception for multiple circumstances, and I strongly suggest that you don't do that. In other words, if you do a select into with no row and no data is found, then Oracle raises the no data found exception. If you try to touch a row in a collection or an element in a collection at an undefined index value, Oracle raises the same exception. If you want to avoid raising this exception, you can use the exists method to check to see if the index value is defined. So, attach the exists method to the variable with dot notation, pass it the index value you want to find out about, and if it exists, then do whatever you're going to do, like display the value at that point in the collection. Let's take a look at an example. Now we're going to spend a fair amount of time with the PL/SQL loops file looking at various ways that you can iterate through collections. But here's an example of the use of exists. I'm going from the first defined row, we're about to take a look at these methods as well, to the last. And before I try to access that variable or the element in that collection, I'm going to ask, does it exist? Now let's take a look at another file just to demonstrate what happens if you try to touch a row that does not exist and erases the no data found. So here's an example of declaring an associative array, table of strings, indexed by integer. There's my variable based on that type, and I populate it with 4 rows of information. Now, the main thing I want to show you here is the raising of no data found, so let's not worry about all the details. You'll see that in my separate lesson on associative arrays. But what I'm going to do is ask to show the value at location 2. Notice I've defined an element at index value 1, index value 3, index value 88, and so forth, but not at index value 2. So let's actually do 2 things. I'll try to display the value at index 1 and then 2. I run my script, and notice no data found at line 14. So it looks just like a select into error, but in this case I'm trying to quote-unquote select from a collection. Same error. But if we look at the output, notice it showed me the name of the person at index position 1. So that's the thing to watch out for. You might try to touch a row that doesn't exist or an element that doesn't exist, and Oracle raises no data found. The way to get around that is to first ask, does it exist? So for example, I can say, if happy family exists at position 2, then display that name, else we'll display no name at index 2. Now when I run this code, notice I no longer get an exception. I check to see if it exists. If it exists, I would display the name. Otherwise, I would display this string. And now when I look at my output, you can see that it took that branch of code. So there's an example of using exists to avoid the no data found exception. And let's save that for future use. So that's the exists operator, or exist method. Now, the most important methods are those that help you navigate through collections because, of course, when you build a list of elements, you're likely going to want to move through those elements to perform certain operations, displaying them, moving the data from one collection to another, and so on. And in general, you can use all the different kinds of loops available in PL SQL to perform the navigation: while loops, simple loops, for loops. But one of the questions will be figuring out which sort of loop to use depending on the characteristics of your collection. So that's what we're going to explore now. So choose the right loop. In general, you only want to use a for loop when you're iterating through every element between the low and high index values. In other words, go from first to last, go from 1 to count. But don't do conditional exits. That's the key thing. With a for loop, when you're saying, I'm going to move through every element in my collection, do not have a conditional exit. Also, do not use with sparse collections. In other words, if I have an element defined at index position 1 and an element defined at index position 10 and nothing in between, a for loop is not a good match because I'll hit no data found exceptions. When I've got a sparse collection, when there might be gaps between my lowest and my highest, or if I want to conditionally exit from my loop, then I should use a while loop or a simple loop, otherwise known as an infinite loop. So let's take a look at navigation methods and the for loops, and then we'll take a look at the while and simple loops. So with for loops, it's pretty simple. You're going to use the count method when the first index value in the collection is 1. You use first and last when the first index value might not be 1. So let's take a look. Here's an example of iterating through the contents of my collection, and I'm assuming that every index value between 1 and the count, let's say 100 or 1,000, is defined, because notice, if I try to touch that element at that index value and it's not defined, I'll get a no data found exception. So 1 to count should only be used when you know that every element is filled from the first index value, the lowest, to the last, or count. Now, if it so happens that your collection is densely filled, whoops, that's a typo, that should be first, my apologies, let's get out of here. Let's fix that. Should be first. Back in we go. So in the second example, I'm saying that my collection may not start at 1. Maybe the first value, the lowest value in my collection, is actually 15. So this is a more general formulation. It does not make an assumption that the collection is filled from index 1, but it does assume that every element between first and last is defined. Otherwise, again, we'll raise the no data found exception. Notice the reference to the PL/SQL loop script. What I'm going to do is walk through the different kinds of navigation. Then we'll take a look at this file and explore the different approaches. So again, with sequentially or densely filled collections, you can use a for loop as long as you don't have conditional exits. Just go through every element in my collection. And the only question is whether you want to use 1 to the count or first to last. So navigation methods and while or simple loops. Now, you'll use a while or a simple loop if you have to conditionally exit from the collection, or more likely the scenario is that your collection is not sequentially filled. Not every element between first and last is defined. So with while and simple loops, what you want to do is use the first method to get the lowest defined index, and then move to the last with the next. Hop over any undefined elements. If you want to go from the end of the loop, end of the collection, to the beginning, then you start with last and use prior to go to the previously defined index value. So in general, your loops will look like this if I'm starting at the beginning and moving to the end. Declare my index value, initialize it to the lowest defined index value. And here's a simple loop. Exit when the row index is null. So in other words, there's nothing more to do, or the collection is empty. Do whatever I'm going to do, and then call the next method, passing it the current index value and saying, get me the next one up higher in the list, and that returns the index. When I'm at the end of my list, end of my collection, last or next returns null. Conversely, if I want to start at the end of my collection and move down to the first, I would call the last method as my starting point, exit when my index is null, use the prior method to say, okay, I'm at index position 15, go to the prior one. That might be 14, it might be 11, it might be negative 16 million. Doesn't matter. The prior method will return it. We go to that one. And if I'm at the first or lowest defined index value, and I call prior, then prior returns null, and my loop will stop. So let's take a look at these different approaches to looping. So in PL/SQL loops, what I've done is create a procedure called show birthdays, and I pass in as an argument the second index value or second row number. Now what I've got inside my procedure is a list of dates. This is an associative array, table of dates, indexed by integer. And there's my variable based on that collection type. Now what I'm going to do is populate this collection with the 2 birthdays of my children. Chris, born in 72, Eli, born in 86. And I'm always going to put my older son's birthday in the first element, index value 1. The index value for my second birthday, my younger son, is defined by the parameter value coming in, so it's not fixed. It's not necessarily sequentially filled. Let's take a look at all the different ways I can iterate through this collection. I could say, well, let's just go from first to last. That's assuming that my collection is sequentially filled, so I get the birth date for each element defined in my collection. But if second row is not equal to 2, then I'm going to say go from 1 to, suppose, let's say 15. And as soon as it tries to go to index value 2, it should raise a no data found exception. And notice I've trapped it there, and I display a message. Here's another approach I could take. Well, go from first to last, go from 1 to 15 or 1 to 2 million. And to avoid no data found, I'll say if the birthday exists, then get the birth date. So this way I don't have to worry about raising a no data found exception error. I won't look at this row unless I first verified that the row exists. Here's another approach. Going from first to last, if my collection is empty, I could run into a problem. So this basically says, okay, NVL, if the first is null and the last is null, if the collection is empty, then go from 0 to -1. In other words, don't do anything. And in this case, what I'm going to do, instead of trapping the checking for exists again, I'll trap no data found, say that's all right, do nothing, and keep on going. So here's an example of having a loop in which I try to get the index value, or I try to get the element at a specified index value. If the exception occurs, trap it and keep on going. In the first example of using no data found, the entire loop stops the first time it touches something that doesn't exist. Well, okay, I may not want to do that. I may want to continue. So, in this approach, I'll keep on going through all the elements in my collection from first to last. And if I don't find a match, just keep going. By the way, this is a very poor practice, swallowing up exceptions like this. But it gets the behavior I want, which is to keep going even if I run into an element that's not defined. Then finally, I have my while loop instead of a simple loop that says start at the first, while my index is not null, get the birthday, go to the next element. And what I've done is run this code for two scenarios. In fact, let's run this code for a couple of scenarios, and then we'll take a look at the timing aspect, the performance aspect of this. So I'm going to create my procedure, and then I'm going to run it. Now, first of all, let's just run it for show birthdays 2. So, because I'm passing in 2 for the second index, notice that my collection is densely filled 1 to 2, so first to last doesn't have any gaps in it. So when I show the birthdays, it says timings with second row, check exists. What you're seeing here are the timings. There were no errors that occurred, so I only see the timing reports, which are not very interesting right now. But the main thing is we don't see any no data found exceptions. Didn't try to look at an undefined element. Okay, now if I do it again, and I specify, let's say, 15 for my second row, then when I run this code, notice it now says, try to look at undefined element. So in the case where I didn't trap the exception and allow it to continue, which is right here, the first time it went from 1 to 2, because it was going from 1 to 15, it tried to touch the row that didn't exist, raise the exception, display the message. In all the other cases, I've handled the situation with either the exists operator or trapping the exception and continuing. So it didn't show me any message, and I didn't have an error. So that's the difference in behavior between having something that's densely filled and sequentially filled. With the 1 to 15, I got the message. In all these other cases, I was able to avoid getting a no data found exception. But let's talk about the optimal algorithms here, because as you can see, and as is almost always the case in programming, there are multiple ways to accomplish the same thing. I want to iterate through all the elements in my birthday list. I can go from first to last with exists. I can go from first to last trapping the exception. And I can use my while loop. And what you'll find is that the performance of these different approaches can vary greatly. For example, when I ran show birthdays with a second index value of 10 million, or sorry, of 1 million, so my first index value is 1, my second is 1 million, what you'll see is that you can pay a very significant performance price depending on how you write your loops. So first of all, let's go to the bottom. Using first and next, so my while loop, it took less than 1/100th of a second to perform my loop through those two elements, which is not surprising. It's just two elements. But notice with my trap, no data found each time, it took 1.7 seconds. Much, much faster. Well, sorry, much, much more time, much slower. And that's because what it did was go from 1 to 1 million. It did it 1,000,000 times. It iterated the loop 1,000,000 times and trapped the exception, raised and trapped the exception 1,000,000 times. And raising and trapping exceptions is quite slow in PL SQL. So 1.7 seconds to process that same, to run through the same data, that took me less than 1/100th of a second using my while loop. And notice check exists each time took 0.16 seconds. And what you see here is the overhead of calling the exists operator over and over again. Now 0.16 seconds over 1,000,000 iterations is not terribly slow, but still, it's a noticeable amount of overhead that's totally unnecessary. If you're iterating through a collection that is not sequentially or densely filled, you should always use the first and next or last and prior methods to navigate through the collection. because then no matter how the data is distributed in your collection, whether it's densely packed together, whether it's very loosely defined in which you have a range of index values which are very large compared to the number of elements in your collection, you will still get the same good performance. So the bottom line for loops is use the while loop or simple loop whenever you have a non-densely filled or a sparsely filled collection. You can use the for loop, either going from first to last or one to count, depending for sequentially filled collections, depending on what the first value is. If it's 1, you can go from 1 to count. Otherwise, first and last. The final collection method that gives you information about a collection is the limit method. The V-array is a special type of collection in which it has a predefined or upper limit. So you can say when you declare the collection, this collection can have no more than 5 elements. And here's an example. So this V-array, or a variable based on this V-array type, can have no more than 5 elements defined in it. And if I want to find out what that limit is, I can call the limit method. So I declare my new type of collection. I declare a variable based on that collection type. I initialize it. We'll talk more about this under nested tables and V-arrays. And then I display the limit. And when I run this code, I see 5. So that's what the limit method does for us. Okay, let's finish up this lesson by talking about methods that change a collection. The most common would be the delete. Delete one or more rows from the collection. Extend adds rows to the end of a nested table or a V-array. And trim removes rows from a V-array or a nested table. So the delete method, you can delete one or more rows from an associative array or nested table using delete. You cannot use delete with V-arrays. In fact, you'll get a PLS 306 error, wrong number or types of arguments if you try to delete from a V-array. You can specify a range of values for your delete, so there are multiple formats for the delete operation. First, I can simply say .delete, so there's my method attached to my variable. .delete says get rid of everything in my collection. Empty it out. So the count after a delete like that is 0, always 0. I can specify a single element to be removed from my collection. In this case, I'm saying get rid of the last, the end of the list, but I could specify any index value. And I can also specify a range of values. So get rid of everything between 1400 and 17,255. And if you do specify a range, these index values do not have to be defined. Anything between those two values will be erased. Let's take a look. So here what I'm going to do is declare a collection of records, another associative array. I'm going to populate my collection of records with a bulk collect query. That's bulk processing. I'm going to get rid of the first one. I'm going to get rid of everything between 7 and 20. Let's fix my typing there. Here's an example of deleting all the even rows. So go from 1 to the count in my collection. If the element exists at that location, and the mod of that index in 2 is equal to 0, delete that element, and then delete all the remaining rows. So let's try that out, see if I get any errors. So no errors, and it did all the individual delete operations. And if we try to delete from a V-array, we should see some very different behavior. So you cannot delete from a V-array. You can only trim off the end of a V-array. V-arrays are always densely filled. The delete operation, as you can see, can introduce gaps in my collection. Get rid of everything between 7 and 20. Get rid of just the even indexed, even elements. So by doing these kind of delete operations, you can introduce gaps between first and last. This is true for nested tables and associative arrays, but you cannot delete from within a V-array. You can make room for new elements with extend. Extend is only for use with V-arrays and nested tables. And what you're basically doing is telling Oracle to make room for n number of new elements at the end of the collection. And you can specify one at a time, or you can specify bulk extends, in which I could say, well, I know I'm going to need 10,000 rows, so let's extend 10,000. And you can also specify the value of the new element from an existing element. Let's take a look. So here's a nested table of employee records, and I'm going to initialize my nested table. We'll talk about initializing in a separate lesson. I'm going to make room for one element, so extend without any parameters. That means that there's now an element defined at index value 1. I can assign the last name, the first name, etc. If I want, I can do bulk extending, so extend 5 more rows. Now I've got a total of 6 elements defined in this collection. And I can even say, well, extend 10 and set all the element values to the same value found in index position 1. And after doing all of that, I should have, let's see, 10 plus 5 plus 1. I should have 16 elements defined. So what I'm going to do is iterate from 1 to the count and display the first and last names at each one of those locations. Let's try it out. Let's see what I get. In fact, let's do that again. Get rid of all that previous text. And what it shows me is that index value 1 has Engelbert Ellison as the employee name. From 2 to 6, no name at all. And from 7 to 16, Engelbert Ellison. So why did this happen? Why do we see this output? Well, at index position 1, I defined explicitly the last name and first name of that employee. I then extended 5. I did not provide a default element, so it automatically extended 5 records, but everything in the records are null, so the name is null. For the next 10, from 7 to 16, I specified use whatever value is in index position 1. So notice all the names for those records are set to the same. Now the following script, in the extend SQL script, there's a block of code here that demonstrates the performance advantages of extending in bulk rather than extending one at a time. So there's individual extends for 1 million iterations, or sorry, 10 million. Here's a 10 million extend all at once. And then also the alternatives in terms of extending and adding a value, or extending and then reference the previous value. And on 11.2, you see some significant differences in performance. So individual extend, 10 million extends, 1.75 seconds. Bulk extend, 0.06. So generally speaking, if you know you need to extend n number of rows, do it all at once versus incremental extensions. Trimming elements from end of a collection. This is available only with V-arrays and nested tables, and this is different from the trim function, which is a string function that trims characters leading or trailing on the string. You can trim one or multiple elements, get rid of the last element in my list, get rid of the last 10. And if you try to trim more than is in the collection, you'll get the subscript beyond count error. Trim is the only way to remove elements from a V-array. You cannot do a delete. Let's take a look. Okay, in my trim program, I have a collection of records. I populate all the collection from the employees table. I find out how many elements I have in my collection. Sorry, the last defined index value in my collection, which is the same as count in a V-array. Whoops, this is a table. Sorry, not a V-array. It's a nested table. So this shows me the number of rows defined in my collection, which is the same as the count of rows, since it's populated with a bulk collect. Then I'm going to trim a single element off the end, and I'll see what my new last value is. And when I trim off 10, we'll see what's left after that. Whoops. Okay, so last index first is 107. So the employees table has 107 rows in it. I'll prove it to you. It has 107 rows in it. So when I do a bulk collect, I've retrieved all the data from that collection, populated my collection, sorry, all the rows from the table, populated my collection, 107 rows. I trim once. The last is now 106. I trim 10 times more, and the last is 96. So it's pulling them off the end of the list. Is it faster to trim in bulk or individually? Same question as with the extend operation. What if I know that I'm going to be trimming a whole bunch at once, and I found again that trimming iteratively is slower than trimming in bulk. And depending on the number of elements you're trimming, it can make a big difference. 12 seconds to trim 100,000 times versus a single trim, 0.01 seconds. So again, if you know you're going to be trimming a lot, don't trim inside a loop, trim in a single operation. But in any case, for nested tables and V-arrays, it always is pulled off the end of the list. Whereas the delete operation, the delete method, gives you the flexibility to specify which index value you want removed. Drawing some conclusions. So methods in general make it much easier to work with collections. If you couldn't ask about the count, if you couldn't do deletes, if you couldn't navigate with first and last and next and prior, in other words, if your collection was a black box, an opaque structure, it would be very difficult to work with it. The collections really open up, the collection methods really open up collections, making them easy to work with, easy to understand their contents, easy to manipulate. But remember, when using the navigation methods, particularly when you need to iterate through the collection, make sure that you use the appropriate type of loop to iterate through the different elements. If your collection is densely filled, then you could use a numeric for loop, and if you know it's always going to be densely filled. If your collection might be sparse, it might have gaps between first and last, then you should always use a while loop or a simple loop.